Alright, let's go ahead and check your warm-up answers. I know it says tip off on top, still means warm-up. So with number 1, we're writing it as a single logarithm. So we want to go from 2 into 1. So I know I'm going to have a log base 2. There's addition here, which means in single log there'll be multiplication. So I'm going to be multiplying the 5 and the x. 5x stays 5x, so here is your answer to number 1. Number 2, we're expanding, so we have to make sure we take it into consideration every single part. So in this part, there are 3 things. There's an a squared, a b, and a c, which means we're going to have 3 logs. The first log is going to be a squared. Then it's being multiplied to b, so that means we're going to change it to addition, log b. And then this entire thing is being divided by c, which we're going to change into subtracting by the log of c. Now, hopefully you notice there's still one more thing we need to simplify. If you did it at the beginning, that's great. This exponent, anytime we see an exponent and we're expanding, we want to move it from here to the very front. So this is going to become 2 log a plus log b, still in parentheses, minus log c. Going over to number 3, this time it says to use the change of base formula. So you should have set it up to be log 7. And remember, it's always divided by the base. Think of it as the below number, so it has to be on the bottom of the fraction. So again, hopefully you just were able to type this directly into your calculator. So some of you would have typed in the 7 first and the 3 first and then the logs, and some of you did the opposite. It didn't tell you where to round to, so I'm going to go ahead and round to the thousands like your homework, and that would be 0.477. Here are the homework problems from last night. 33 through 38, you were writing them from multiple logs into 1. Number 36, either one of those is acceptable if you went ahead and took 8 to the 5th power, or if you put the 5 in the front. I could understand both methods. 39 through 44 are like warm-up number 2. Make sure that anyone that had exponents, those numbers went out to the front, and none of these needed parentheses. And again, you can always pause this if I'm moving too fast with the answers. And then the last 3, change of base. 45 was 0.4, 46 was 1.5, and 47 was 1.792. So if there's any questions, make sure you discuss it among yourselves. And then we're going to be starting the next section today, 4-5. Today we're going to talk about exponential equations. We talked about log equations already. We'll talk about them again. But an exponential equation, the first type that we're going to look at are those that have the same base. And again, that base is the number that's connected to the exponent. If they have the same base, or you can make them have the same base, then we first start by rewriting each side with the common base. And then we're going to use the power property of exponents. The power property of exponents, what that one says is if I have 2 cubed squared, we take the exponents and we multiply them. So this would become 2 to the 6. Okay, so that's what that's referring to. If the bases are the same in step 3, we're going to set their exponents equal because if they have the same base, then your exponents have to be the same in order to have an equation. And then we're going to solve for the variable. So those are going to be our 4 steps for when the bases are the same. So we first start with looking at our example here. Now 16 and 8 aren't the same base. So what I have to think of is there a number that's the same that I can use with an exponent? For example, is there a number that I would raise it to a certain power to get to 16, and I can use that same number for 8? With this one, both of these have a base of 2. We're going to change their bases to 2. Well, to get to 16, you have to take that 2 4 times, but there is already a 3x out there. To get to an 8 from 2, you have to do it 3 times. Well, the product property, power property, says we're going to multiply those 2 exponents there. So that's going to become 2 to the 12x, and that's equal to 2 to the 3rd. Well, since their bases are both the same, we're going to set their exponents equal to each other. So I know that 12x has to equal 3, which means we're going to divide both sides by 12. So x would either equal 0.25 if you simply did that in your calculator, or 1/4 if you noticed you could divide them both by 3. Okay, so again, the first thing is you have to make sure that the bases are the same. And that means that you're going to make it into a smaller number that you could use an exponent with to get back there. So go ahead and try the first you try on the right there. The 27 3x to the 3x equals 81. And again, the first thing is you've got to figure out what number could you change a 27 and an 81 both into using exponents. Hopefully you have the you try done and you've checked it with the neighbor, so you're pretty certain that you have the right answer. The number that you should have changed them both into was a 3. Well, to get to 27, you have to take a 3 3 times. And there's already a 3x there. To turn an 81 into 3, you would have to have that 3 4 times. So we're going to multiply these together. So I have 3 to the 9x is equal to 3 to the 4th. Bases are the same, so we set the exponents equal to each other. 9x equals 4. Means we're going to divide both sides by 9. This does not turn out to be a nice simple fraction, so I'm going to leave it as 4/9. If you went ahead and changed it to a decimal, since that decimal with this one would be repeating, I would leave it the 4/9. The decimal equivalent or approximation would be 0.4 repeating. Going to our next example. 3 to the x plus 2 equals 27 to the 2x. You're going to start recognizing the same numbers over and over. Your 16, your 8, 27, 81. In this case, one of them already is the correct base, so we're going to leave the 3 to the x plus 2 alone. I can change that 27 into a 3, and it's 3 to the 3rd, and then to the 2x. So again, the left side we're going to leave alone. On the right side, I'm going to use my power of exponents. So this will become 3 to the 6x. Now that our bases are the same, we're going to set the exponents equal to each other. So x plus 2 equals 6x. And this one's a little bit harder to solve for x, but not much. So we need to get our x's together on opposite sides, so we do the opposite. So I have 2 is equal to 5x, divide by 5, so x equals 2/5. Yes, you could change that to a decimal, which would be 0.4, but there's no reason to. You can just leave it as a fraction. So now go ahead and try the next you try. Solving for x, check with a neighbor as you go along, and then unpause the video when you're ready to completely check your answer. Hopefully you recognized that your base here is going to be 2. This one you're just going to leave alone, and this one we're going to change to a 2. So we have 2 to the 5x plus 1. 32 to change that to a 2, it's 2 to the 5th power. Now on this one there wasn't another exponent, so the 5 is going to stay 5. Now since they both have a base of 2, we're going to set the exponents equal to each other. 5x plus 1 equals 5. Subtract 1. So I have 5x is equal to 4. Divide by 5. And x equals 4/5. If you went ahead and changed that to a decimal, it would be 0.8. But again, you really don't need to. So hopefully you did well on that. You try as well. So now there's 4 practice problems that I want you to try to give yourself some more practice. Feel free to check your answers with a neighbor as you go along, and then unpause this when you're ready to check all 4 answers in the class. Number 1, one of them already had the correct base, the 2 to the x, so we just need to change the 8 into 2 to the 3rd. Well, since the bases match, we set the exponents equal to each other, so x simply equals 3. X is already solved for, so there's my answer for number 1. Number 2, if you notice, one of the bases is already taken care of, this 3, because I can turn a 27 into a 3. So I have 3 to the 2x, that's going to equal 3 to the 3rd. The bases match. There's no simplifying, so we go 2x is equal to 3. Divide by 2 to solve for x. So x equals 3/2. Or if you changed it to a decimal, 1.5. Number 3. Now, number 3 you could have done a couple different ways. One, you could change 4 to be a base of 2. And you can also change 64 to be a base of 2. But hopefully you recognize that 64 could actually be written as 4 to the 3rd power, which means we don't have to change the 1 here. I'm going to show you with the 2's as well in just a second. So since the 4's match and there's no simplifying, 3x is equal to 3. Divide by 3, x equals 1. Now, if you had changed them into 2's, the 4 would have become 2 squared, and then multiplied to the 3x. And 64 is 2 to the 6th power. So then we would have had 2 to the 6x equals 2 to the 6. 6x equals 6. Divide by 6. X equals 1. So you still get it. So this way, because the basis could have been one of 2 things, you could have done it either way. Next practice problem before we move on to our next skill. Here we have a 3, which means I need to turn an 81 into a 3. And I'm going to do that because 3 to the 4th is 81. So I'm going to bring down the other side. There's no simplifying of exponents here. The bases match, so it's simply negative 2x plus 2 equals 4. Subtract 2 on both sides. and then divide by -2, x equals -1. Hopefully you did well in those 4 problems. So again, those are exponential equations when you can turn them into the same base. The second skill learning for today is solving an exponential equation when the bases are different, when they can't be made the same. Now, technically you could also use this when the bases are the same if you do prefer this method. So this one we're going to introduce a log. So you're going to take a log base 10, because base 10 is what we can use in the calculator, of each side. We're then going to use the power property of logarithms, and then isolate the variable. So here are your steps, so now let's put them into action. So here's our first example, and we'll show you what we mean by bases that you can't make the same. We have a base of 15 and a base of 285. Well, the first thing with the 15 is I know I can't make that 15 a smaller base. You know, 2 to some exponent is not 15, 3 to some power is not 15, 4, 5, so on. So the only way to solve this using the same base is if I could turn this 285 into a base of 15. Well, we can check that. I know that 15 to the first is 15, so that's not 285. 15 squared is 225. Well, that's not 285, and I know that 15 to the third would be even higher than that. It definitely wouldn't be in the 200s anymore. So since I can't make them have the same base, we have to approach this a little bit differently. And the first thing we do is we introduce a log into the problem. Now remember the rules of equations. What I do to one side, I do to the other. So if I insert a log on the left, I have to insert a log on the right. Now, the second step talked about that power property of logs. The power property says I can take this 3x, which is an exponent, and move it out front and multiply it by. So I now have 3x log 15 is equal to log of 285. And now I'm going to isolate x. Well, the first thing I'm going to do is take care of the logs. So I'm going to divide by log of 15 since it's attached by multiplication. On the left, I'm left with the 3x. On the right, I'm actually going to do that division here. It's kind of like the change of base, so remember how you type in your logs, whether you type in log or the number first. So go ahead and do that. And you should get 2.087. We're going to end there. Well, x is still not by itself, so we need to divide by 3. And you should get that x equals 0.69. We're going to round it to the thousandths, and I'll turn that 5. That's in your calculator to a 6. And there's the answer for x. So now go ahead and try the U-try problem following the same steps. Check with the neighbor as you go along, and then unpause it to check your answer. So again, 130, you can't turn that into a 5. So we're going to use the same steps. So we're going to introduce a log. Then we're going to use our property to take the exponent to the outside, or to the front. And then we're going to divide both sides by that log. When I take log of 130 and divide it by the log of 5, I now have that 2x is equal to 3.024. Divide both sides by 2, and x equals 1.512. Now let's look what happens when we have an addition or subtraction sign along with the problem. So our next example, we have 2 to the y plus 1 is equal to 25. Well, I know that I can't turn 25 into a base of 2. The only base I could turn 25 into is a 5. So we're going to insert a log. On both sides. We're going to use our power property to take that exponent to the front. So this becomes y plus 1, and I'm going to put it in parentheses, of log 2 is equal to log of 25. We're going to divide both sides by that log of 2. So I now have y plus 1 is equal to 4.644. Now hopefully you're keeping the number on your calculator. Don't clear it out, just simply leave it there. And then all you have to do on that calculator is simply subtract 1, or you could do that on your own here, because you'd be subtracting 1 from the 4, so that would turn it into 3.644. Go ahead and try the next U-try. So here we go, we're going to insert a log to both sides. You should have taken the exponent and put it out front in parentheses. Divided both sides by that log of 25. And I have 2x plus 1 is equal to 1.544. Again, don't need to clear it out on your calculator screen, just leave it there. So now we're going to subtract 1. So in your calculator you can just hit 1 so it stays on your screen, and that gives you that 0.544. And then on your calculator you can go ahead and type in the divide by 2. And x should equal 0.27, and we're going to round that 1 to a 2 since a 9's behind it. And there's your other U-try problem. You're now going to try 4 more problems on your own. They should be at the very bottom of your notes. And then unpause the video to check the 4 answers when you are ready as a class. Number 1, there's no way to turn a 2 and a 3 into the same base. So we're going to go log 2 to the x equals log of 3. Put that x out to the front, changing by the power property of exponents. Divide both sides by log of 2. So x equals here 1.585. Number 2, hopefully you noticed that there was something different about this problem than anything you've seen, and it was that 8 out here. So we want to isolate your exponent, so we're going to subtract that 8. So I have 10 to the x equals 1,000. Now, there's 2 ways that you could have done this problem. 1, these can be turned into the same base, or 2, what we've just been doing. So I'll show you both here. Let's first start with what we've been doing. So you have log 10 to the x equals log of 1,000. Put the x out in the front. Divide both sides. I'm going to change up colors here so it stands out by log of 10. So we've got x equals 3. So that's the method that we've just been working on. Now, and again, you also could go back and do that using the same base, changing that 1,000 into a base of 10. Going on to number 3. So 9 and 66, those aren't going to turn into the same base. So we have log 9 of the 2 to the 2y equals log of 66. Put that 2y out front. And then we're going to divide both sides by log 9. So I would have log of 66 divided by log 9. And I would get 2y is equal to 1.907. Now again, just don't clear your calculator screen. Keep it up with all the decimals in it. Divide by 2 to get y by itself. And then y equals 0.953. So again, the best method is just leave your calculator up and go through the steps on your calculator. Last one for today, number 4. 2 and 5 aren't going to become the same base, so we've got log 2 to the 3x minus 4 equals log 5. Put that 3x minus 4 out front. Divide both sides by the log of 2. So I now have 3x minus 4 is equal to 2.322 if I round it. And again, just don't clear it out on your calculator screen. So now we're going to isolate x, so we're going to add 4. So go ahead and simply add 4 to all those numbers. And now we're at 3x is equal to 6.322. Divide by 3. And again, type that into your calculator. And our final answer is x equals 2.107. Sorry, it squeezed in there.